Our topic for the day is Newton-Raphson method. Newton's method, also called the Newton-Raphson method, is a scheme for finding a numerical solution of an equation of the form f of x equals 0, where f of x is continuous and differentiable and the equation is known to have a solution near a given point. So the method is illustrated below. The solution process starts by choosing point x sub 1 as the first estimate of the solution, and the second estimate, x sub 2, is obtained by taking the tangent line to f of x at the point x sub 1, f x sub 1, and finding the intersection point of the tangent line with the x-axis. The next estimate, x sub 3, is the intersection of the tangent line to f of x at the point x sub 2, f x sub 2, with the x-axis, and so on. So mathematically, for the first iteration, the slope f prime of x sub 1 of the tangent point x sub 1 and f x sub 1 is given by the formula f prime of x sub 1 is equal to function of x sub 1 minus 0 all over x sub 1 minus x sub 2. And solving for x sub 2 gives the formula for x sub 2 equals x sub 1 minus function of x sub 1 all over f prime of x sub 1. For the algorithm of Newton's method, first, choose the point x sub 1 as an initial guess of the solution. So you have to provide number as an initial guess. For number 2, for I equals 1, 2, and so on. Until the error is smaller than the specified value, calculate x sub I plus 1 by using the formula x sub I plus 1 is equal to x sub I minus f x sub I all over f prime of x sub I. So, when are the iterations stopped? Ideally, the iteration should be stopped when an exact solution is obtained. So this means that the value of x is such that f of x equals 0. So generally, this exact solution cannot be found computationally. So in practice, therefore, the iterations are stopped when an estimate error is smaller than some predetermined value. A tolerance in a solution, as in the bisection method, cannot be calculated since bounds are not known. Two error estimates that are typically used with Newton's method are the estimated relative error. So here is the formula for estimated relative error and the tolerance. So let's have sample problem number 1. Find the solution of the equation 8 minus 4.5 times x minus sine of x equals 0 by using Newton's method and calculate the first two iterations on paper using 6 significant figures. For our solution, first we have to arrange the equation f of x is equal to 8 minus 4.5 multiplied by x minus sine of x. So we will distribute 4.5. So f of x now is equal to 8 minus 4.5 of x plus 4.5 sine of x. Then next, we have to check for the sign change. So we substitute x by 0 to solve for f of x. So the result is 8. And if we substitute 1 to the equation, the result will be 7.28662. And if we substitute 2, the result is 3.09184. And if we substitute 3 to x, the result is minus 4.86496. So with this, the root lies between 2 and 3. Take note, we have to multiply the angle by 180 over pi to convert it into degrees. Next, take the first derivative. So f prime of x now is equal to the derivative of 8, which is constant, is 0, minus derivative of minus 4.5 of x is minus 4.5. and the derivative of 4.5 sine of x. So the derivative of sine is cosine. So the result is 4.5 cosine of x. To simplify, we have now f prime of x is equal to minus 4.5 times 1 minus cosine of x. Then to start the iterations, f of x and f prime of x are substituted. So using the formula, and then for the first iteration, use I equals 1 and x sub 1 with the initial guess of 2 gives x sub 2 is equal to 2 minus 8 minus 4.5 times 2 plus 4.5 times sine of 2 multiplied by 180 over pi all over 4.5, 1 minus cosine of 2 times 180 over pi. The result is 2.48517. To continue, for our second iteration, use I is equal to 2 and the x sub 2 will be 2.48517 and gives the value of x sub 3, which is 2.43099. And then for our third iteration, again, use I equals to 3, and now we have x sub 3 to be 2.43099, and it gives the value of x sub 4 to be 2.43046. For our activity, find the real root of the equation minus 4x plus cosine of x plus 2 equals 0 by Newton-Raphson method up to 4 decimal places, assuming x sub o equals 0.5. Perform 5 iterations. The answer for this problem is close to 0.25832. That would be all. Thank you. Have a good day.